Hello students, Jai Sonia. This is the continued lecture of Unit 2 topic number 3. So we in last we discussed the formation of Y bus into the means Z bus into the Y bus. Now let's see the formation of the Y bus and Z bus using singular transformation. Now we use this singular transformation to transform Y bus and means to find out the Y bus and Z bus. So the bus impedance matrix Z bus and the bus admittance matrix Y bus of the interconnected network can be obtained by using the bus incidence matrix that we already seen. If we find out the bus incidence matrix A, then from that we can find out the Z bus and Y bus of particular network, and A is to related variable and parameter of the primitive network that we already studied. What do you mean by primitive network? The primitive network, in primitive network we consider all the branches and the links which are connected as means connected as not connected, and then after we'll solve the network. So that will be the primitive network of the interconnected network. Now from the primitive network equation, we derived that was I plus j is equal to y into v. So y is basically reciprocal of z, so z is equal to v upon I, so y is equal to I upon v. So I the addition of the current and we can say the complex variable which is present in the network. So that's why I plus j from that equation is equal to y into v. You can refer that primitive network theory for this equation. Now from this equation we are pre-multiplying both the side with the help of A transpose. So here A transpose into I plus A transpose into j into A transpose into y into v. Why we taken this A transposition? This transposition indicates the row converts into the column and column converts into the row. So this is the transposition of the matrix of A bus incidence matrix. Now according to the Kirchhoff's current law and algebraic sum of the current meets at any node is equal to the 0. That means A transpose into I will become 0. So that's why A transpose into I is equal to 0. Now similarly A transpose transpose into J is the sum of the current sources of the element incidence at node, and it is a column vector. So that's why column vector indicates that A transpose into J means total sum of the current. That's why it is I bus, means bus current. So A transpose into J is indicated with converted into the I bus. So I bus is equal to A transpose into Y into V. So this will become equation number 2.9. By substituting equation 2.7 means A transpose into I is equal to 0, and 2.8 means A transpose into J is equal to I bus. We can convert this 2.6 like I bus is equal to A transpose into Y into V, where there Y is the admittance, and where A is the bus incidence matrix, means transpose of the bus incidence matrix, and I is the bus current, and V is the voltage. Now if the bus voltage vector is represented by V bus, from the equation of complex power, as we know as we already know the power complex power equation, that is S is equal to I conjugate into V. So from that equation we can write for this bus incidence matrix also. So S is equal to power into the network, means this is the complex power into the network, or we can say apparent power into the network. So that is I conjugate into V. So we have the V is the V bus, and I conjugate we have the I bus, means transposition of the I bus, conjugate of the I. So the sum of the power of the primitive network is J conjugate into J conjugate transpose into V. So that's why the equation will become I conjugate bus in transpose means matrix of this I bus conjugate transpose into V bus is equal to J conjugate transpose into V. So taking conjugate transpose of equation 2.8, it is modified as we know the equation number 2.8. So from this we are taking the transposition of this over here. So this will become A transpose conjugate transpose into J conjugate transpose is equal to I conjugate bus transpose. So but A is the real matrix, so that's why A transpose is equal to A. So that's why from the matrix property A transpose into A transpose transpose of the A transpose is equal to A. So applying this two condition in equation 2.11, so we are putting the 2 in this, so this will become I bus transpose is equal to A transpose into transpose will become A, so that's why A into J conjugate transpose. So this will become the I bus equation. Now substituting the equation 2.12 in equation 2.10 over here, so the value of I transpose, so this will become A over here, this will become A V bus is equal to V, because J conjugate transpose will be cancelled out from both the side. So the equation will become A into V bus means bus incidence matrix A into V bus is equal to V. Now substituting V from the equation 2.13, this is the value in the equation 2.9. So the equation will become I bus is equal to A transpose into Y into A into V bus. Now from this equation I bus by V bus, we are taking the ratio of I bus by V bus from this equation. So I bus by V bus will become Y bus, because Y is equal to Y is the reciprocal of impedance, Z is equal to V upon I. So Y bus will become I by V. So I bus by V bus is equal to Y bus, and Y bus is equal to A transpose into Y into A of the bus incidence matrix. So as bus incidence matrix A is singular, therefore A transpose Y into A is singular transformation of the primitive matrix Y. So and Z bus can be determined that Z bus is equal to Y bus inverse that we seen from the previous theory. So as we are taking Y bus inverse, so this equation will become A transpose into Y into A. So this will be the singular transformation equation for the Y bus and Z bus. The worksheet questions and the assignment questions after this theory, the worksheet questions are why the bus incidence matrix are important, and second question is what is the difference between Z bus and Y bus. Now the assignment question for this particular topic, the define bus incidence matrix. Then the second question is formation of the Y bus and Z bus using singular transformation. Now the important instructions related to the topics is written in the instruction column, so please read it carefully. You can take the snap of this, and if you have any query and doubt related to this topic, feel free to call me, and we can solve our doubts in doubt solving session. This is the sub topic lecture of lecture 2. So we will see 2 lectures on the same day for this particular topic. Thank you very much, student. Thank you all. Jai Swaminarayan.